over 42. All right. What is our interval width? 10. Already we are multiplying by 10 here. All right. From the first one, what will be our first one? So it's going to be 40 plus this. Get the answer there. The answer you are getting there, it is what? Huh? What will be the answer? 40 plus this one. 40? Yeah, because you do it here, right? You study it right there, right? Sure. Yeah, unless you make the bracket. So this will be 27 is going to be 200 and what? 70 divided by 42 plus 40 here. All right? So it's going to be 40 what? 42 point something. Sure. Huh? Is it 42? Not 42.
One.
Huh? Huh? Apatif. Abab. Up. Up. Oh, 42. 42. 40 plus 207 divided by 42. Do that. It's going to be 40. 46 point. Point what? 0.43. All right. What are those? What? Those are years, right? Oh. Those are years. The most important thing is you need to find where you want. 1, 2, fraction. 3, what is the interval width? Those are the most important thing. The most important thing, what we have learned now, from where we have started from, 1, you have to know where do you want between this, right? 2, what is the width, distance width? Subtract. 3, what is the fraction? The fraction that you are looking, because here the issue is, this one is our starting point, right? Right? Huh? The number, this is our starting what? Starting point. 1, 2. You need to find about the fraction. What's the fraction? 8. And you multiply by the interval what? Interval width. And this is the most important thing for you to understand about these issues about linear interpolation. You cannot know linear interpolation if you don't know where do you want it to do. Where? What is your fraction? And what is your interval width? All right? Clear? That's the most important thing.
Why is it important to know?
Now, let's go to Pearson. Let's go to Pearson. Let's go back again to Pearson now. Go to Pearson, the example that I gave you. Here. Let's go to Pearson. I'm raising this. Let's go to Pearson. Now, go to Pearson. Pearson. Right. If you go to Pearson, that problem I gave you. What was that? Which page was that? Pearson. Page 51. What? Pearson. All right. Page 87. 87. Pearson. For the amps. You go to the amps there. All right? Right? 86. Go to page 86 and 87. Right? I'll just read and you have just to follow.
If people
want to find the median
page or your website.
For grouped data, the median is the half value. Since there are 125 observations, where are they taking it from?
And then
they are taking it from
people.
Example 1.45, which is on page 85. Page 85. You add all those, you form a distribution table, cumulative from that table. When you form the cumulative, you discover from that. Are you there on page 85? That table, if you form cumulative distribution, last number muzi padikiza mukaipesa ngati katebo tipapankacha 8 momwemo. Good. Then the question is since there are 125 observation, the median is the 62 number. So this can be found by linear interpolation as follows. Page 86. Are you on page 86? For grouped data, the median is the half of that. Since there are 105 observations, the median is the 62.5, and this can be found by linear interpolation as follows. Since 65 fuses blew at a current less than 30 amps, so they're talking about, if you go to that diagram, they are interested in 30 to 31. Down on the diagram on page 87. Mamba. All right? 8. That's what I'm saying. When it is to do with linear interpolation, first of all, which area are you interested? So what they were interested is area between 30 amp to 31. Clear? What is the interval width? Between 30 and 31, what is the interval width? 1. All right? So that one is the one that you have to multiply that one by 1 at the end. Right? You remember it? Now, another thing is you need to find the fraction. All right? The starting point is 30. All right? So it is 30 plus the fraction times the interval width. Is it okay? Do you understand? Yeah? So what we are saying there is you need to find that is 30, the first one, plus what? Yeah? Aha, the fraction. Times what? Interval width. So where is this fraction? What fraction are they taking it? This fraction, they are taking it from the beginning. So it's something like this. You have 30 amps here. 30 to 30 what? 31. It's this one. Median is here. All right? Median is there. All right? So you take all there from up to here, which is there 45. All right? And from there up to 31 here is 70 what? 75. All right? Here is 45, 75. What will be here? Take it. What will be? No. And this the median here is what? 62.5. So if the median is 62.5, the median from there up to here, it is 62.5. 62.5 is from there up to here, right? And from here to here up is 45. You can find it from here to here, right? Take 62.5 minus 45, all right? Is what? 17.5. So if that is 17.5, what is 17.5 of the whole of this one? So this is from there up to here, it is 75. 8. And from there up to here, it is 45. What will be from here up to the 8? 75 minus 40 what? 45. Which means what? 30. So our fraction is going to be 17.5 over 30 times where is this one? Interval width. So here you are adding, what will be here? is 30. That's how you get the interpolation. Right? So what you get it from, this one is the value you are interested. And this one, it is the fraction. And one is the interval. That's how it's very simple. Only that maybe we can get complicated and one when we are starting it. All right? No, it depends. Now let's go to, when you do that one, you can, what you are getting, you are estimating the mean. So that is now Pearson. Now Pearson, actually what I actually said, Pearson, when you go to Pearson, the answers for Pearson, they range. Pearson distribution ranges from -3 to what? To 3. Your answer shouldn't be, it has to lie in between this. If your answer is more than 3, that is wrong. Yeah, Pearson. The answer ranges between -3 and what? 3. If you answer is -2, it's totally wrong. I don't even mind. But what you can guess, you have to calculate. So you have to calculate. So you discover that the answer lies between -3 and what? 3. It can be 2 point something, but it has to range in between that, right? It has to range in between that. All right. Then that is the Pearson. Let me just read the Pearson for 5 minutes, and then we have to go to whisker diagrams. So generally, the skewedness can take between values 3 and -3. All right. If mean is greater than mode, the skewed is positive. If mean is less than mode, the skewed is negative. If mean is equal to mode, it means that is a symmetrical or normal. Normal what? Distribution. Normal distribution. Right. Go to page 89. Go to page 89. Normal distribution. Go to page 89. Go to page 89. All right. Normal distribution. There is a special symmetrical distribution known as the normal distribution. Are you there? This is bell-shaped, centered around the mean. Here are two normal distributions with the same mean, but different standard deviation. Same mean, but different standard what? Deviation. Here are two normal distributions. So we have got two normal distributions, mean is the same, but standard deviation different. So what is making the normal distribution to either that hill to go up and down? Mean is the same, but it's the standard deviation. Standard deviation is the one that is making it to go up or to flatter. That's the standard deviation. There are two normal distributions with the same standard deviation, but with a different mean. If they are having a different mean, that's the area there with the same standard deviation. But if normal distribution generally, if you look at that one, approximately 68%, if you look at the first one, 68% of the distribution lies within the one standard deviation. Number two, approximately 95% of the distribution lies within two standard deviation. Then where you have got 99%, over 99% of the distribution, nearly all, lies within 3 standard deviation. So when we talk about, say, x bar minus x, it means what they are saying is that this distribution, it lies 68%. Where 68%, we have got the major one is 68%, well 95%, the last one is 99 what? %. 99% it is 0.05, because what is remaining is 5%. All right? Right? Huh?
Yeah.
99%, it is 0.01, which is 1 what? If you take 1 plus this one, gives you 100%. Right? 68%,
Remaining with the
68% is what? 32, right?
yeah.
All right, so this is 0.32, which is 32 what? Percent. It is garbage. What I was saying. All right. Now, what does that mean? Where you have got 68%, all right, where you have got 68%, the distribution will lie within 1 standard deviation of the mean. It means the distribution will lie 1 standard deviation of the what? That's the meaning. Clear?
No.
It lies 1 standard deviation of the mean. When you have got something like this, 95%, so the distribution lies between 2 standard deviation of the what? Of the mean. Where you have got this, it means the distribution lies 3 standard deviation of the what? These are the normal one. That's what I talk about it there. So it depends on where it is lying, whether it is lying in 1 standard deviation of the mean, 2 standard deviation of the mean, or 3 standard deviation of the mean. But the issue is something like, if you look at the first one, is something like this. All right, it's something like 68. Normal is here. If you look at this and here, this is 68. This is 60 what? 68%. That is 68% from 100 is what? 32. If it means if it is 32, divide, because there are 2 areas. 32 divided by 2. 32, it is this and that. 16, right? So this side it is 16%, and this side is 16 what? If you add 16%, 16 is 32, right? And this one plus this one is going to be 100 what? So in that context, it is this one which I'm talking about here. The 32, they have added this and this one, this side here. That's why the 32 is coming from. They have taken 16% plus 16%. This is the 32 is they are talking about this side here, 16% and 16%. If you go to 90, this one, the 90, this, what will happen? It will be like this. If you go to the second one, this one, it means it is lying 1 standard deviation from where it is lying 1 standard deviation from the mean. It means that it is lying 1 standard deviation. One side is positive, x bar plus 1 standard deviation. The other side, x bar minus standard deviation. All right. If you go to the second one, then that one is the 95%. So 95. 95 one is going to be something like this. Just bear with me for only 2 minutes. I'm done as you are signing. 2 minutes. All right. For 95, what is happening there? 95, it is this normal distribution. This is your mean. 95, it is 95, it is here. It's asymmetrical there and there. So the area 95, it is the whole of this one. This is 95. 95%. What is remaining from 95 is what? 5. So 5 in the ukundu particles. All right, you add. All right. Therefore, what will be the other side here? 2 point what? 2.5, and again here 2 point what? 5%. If you add this, it gives you what? Aha, that one. Therefore, what does that mean? So what it means there is, this is this side is going to be, if you are to test, when you are to test, you test based on what is called 0.05 level of significance. So testing of this one, we call 0.05, we call this one, they called level, we call level of significance. Level of what? Level of significance. So what are these level of significance? Level of significance is like this one, 5%, 2%, 1%. Level of significance 1%. Right. Now, which means these are the level of significance, which is like 5%. So in other words, the level of significance, where you talk about 95%, level of significance is 0.05. Here, 0.01. Right. Why am I talking this one again? It's going to be x bar minus 2s x bar plus 2. The other one, the 99, is going to be 3 standard deviation. All right. Now, let me conclude as you're writing. Let me conclude this. Why? What is the importance of this? Why am I bothering you about these issues? These are very serious issues here. Right. When they are testing, this is very important when you are testing, especially if you are writing a research and you want to test something. If they want to test medicine, whether the medicine can kill a person or the medicine are very helpful to people, they use level of what? Significance. If they say 1%, if they say level of significance is 0.01, it means it can be almost, it's just one person out of a lot is having a problem with the medicine. When they are testing medicine and they say we are testing it under level of significance, say 0.01, what do they mean is, if they are to test that medicine, they make sure that, assuming they want to do, they want to test a certain medicine, therefore now only whether the medicine is, they are very powerful medicine. All right. Akama kubatsani amaeza kuna I think tukwabasa ntonse amuliro nkwe muno nkwala abetu wabaya whether katemera, right? Moja akapanga akadandaula kuna kuti katemera hii wadizesa sungu, but the rest are okay. They call it level of significance. So they make sure that when the level of significance is very little, like 1%, like 0.01 here, that drug is a very useful drug, which means that drug is very effective. Kama akapeza unena kuti level of significance is 0.32, they can reject this one. But this one is accepted. They can accept it, but this one they can reject it. Why is it that they can reject this one? Because a lot of people are having problems. All right? Assuming they are testing a drug, kuona una kuti mankhwala ndi amalungu, ndi anthu ambiri akama mankhwala aja amalezeresa. All right? The side effects. If they test it at 0.32 and they discover that there are side effects, what they actually do is, they reject that medicine. Now this medicine hasn't been tested very well. They reject it. Unless if they test it and they discover that it is 0.01 level of significance, is when now they can accept the medicine. The next lesson we are learning, we are looking at, we'll look at 2 issues. We'll be looking at the outliers and we are looking at the whisker box diagram. Whisker box diagram and the outliers. After that, we'll learn about regression, we'll learn about Spearman's ranking, we'll learn about product moment, and those we have to learn before you go.
You have 4 weeks remaining.
The carry can carry 1 week. But still, those are at you are supposed to learn regression. You are supposed to learn Spearman's ranking, product moment, probability. Zimene zizi titabangisa mpaka na muphunzira. Kandi waula ndi waula. Mpaka na muzani zabwera pali kyosabwera. That's why ndimava. Zimene tikuzivutisa is ndikuza 99% chani. Ngani nakocheza pamene koma pepo pali ntchito. So I think I have the only thing that we have to do is when I finish teaching like this one, internet is free everywhere. Go in toilet there, you can do your internet. Wherever internet. Why can't you internet and then find out? You can just Google find out some of these issues. They was going to tell you. Just find out linear interpolation. Google and it's going to come there and you're going to see what we are trying to do. So I have preached the gospel. Any problem? Good. I'm going. I'm going.